Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about unique rail freight wagons. So let's dive deep into it. Now first thing you have to understand why we are talking about rail. Well, rail is what we call great mover, as in if you have a lot of people, if you're talking about 100 to 200, use them plain. If you are talking about 1500, nothing works. At that point in time, train is your guy. Same goes with goods. If you're talking about 1 ton, 10 ton, if you're talking about hundreds of ton, thousands of ton, at that point in time, nothing else can beat it. So fundamentally, basically, whenever you have a lot of something, train is your guy. Now, why the heck it is? Well, physics-wise, this is the reason, as in very low rolling resistance. And it's achieved because two almost immovable objects are making love to each other. You have steel wheel on steel rail. Now, whenever your basically car applies torque on the wheel, here's deal. It's not coupled hardly to the road. Like road is made out of generally softer material. It's not, even concrete is not as hard as steel. And second, if it's that black tar material, it has a give to it. And again, you want that give for friction reason. And again, you have rubber and air. So all of those gives a give. So your deformation is consuming energy. Here, there is no deformation. Now again, microscopically, if you do a simulation, you will find it's just that it's negligible. Compared to every other mode of transportation, it's negligible. And because these are not deforming, the contact patch is tiny. Like a train that could have 22 ton per axle could have a patch that is size of 2 coins. That's it. 22 tons going through that. It cannot be done on concrete, it will crack. You do it on basically any sort of tarpaulin road, it will just sink into it. So that's the core benefit. And because none of these are deforming, once you are in rolling motion, most of the energy is actually going into forward momentum, meaning the only hazard for you would be air resistance. So if you're not moving very fast, this puppy can move stuff, like almost touch a sea-going vessel. And if you are compensating for speed, sea-going vessels, while it can carry even more, it just can't carry it fast enough, meaning it takes time. Meaning if you have a good railway, this puppy will move, like it will haul ass, as they say. So fundamentally, it can give you decent speed and punctuality. Again, not very high speed, because at high speed, it will start to deal with air resistance and it will backfire. But decent speed, basically, below 100 miles per hour. 100 miles is also too much. 60 miles, 70 miles per hour. If you want to be like sweet optimum in kilometers, 100 kilometers per hour, this will be like air resistance is almost so small in fractions that friction is the main bearing point. You don't have to worry about it. And again, a nation's health is determined by how good is your freight network. While America has lull in terms of basically when we call a railway system, again, go to American railway system. I have colleagues there, I have family members there. It's like, yeah, Indian railway is better for public. But America does have robust freight network. So again, that's why India built a dedicated freight corridor before it built basically high-speed railway. Again, Vande Bharat, it's our semi-high-speed train, looks cool, it's wow and all that, but in terms of moving country forward, in terms of increasing GDP, freight network. If you have a decent, trustworthy, reliable freight network, you're gonna print money. Like, I have to say, like somebody in India does understand this part. Now, what is a basic starting point? Basic starting point is a box. You just have a box. Great for raw stuff. For example, iron ore and coal. Coal is the primary one. Now, these are the cheapest wagon. There's just a box. Now, to dump the box, you rotate the box, the whole box. Basically, the whole wagon, you just go, toing. So it does work. Like it does have high throughput. You are talking about 5,000 to 15,000 ton per hour. Basically, that's how quickly you can load up. As long as you have rail preloaded, dumping can be done bonkersly fast. 5,000 to 15,000 ton per hour, that's bonkers. That's good enough that it can maintain a very power-hungry coal power plant, which has like, multiple boiler. It's like, bro, I got this. It can maintain it. And generally, you don't run coal power plants on this. This feeds a buffer feeds the fire. So you do that. Now, be mindful. Why the heck there is so much range? Well, of course, first is the dimension of the bogie. Second, how they are designed. Like this is a simple Indian design where you have a box, you disconnect it, you have a small shunter locomotive which is integrated there. It pulls the stuff, locks it, Then you unlock it, you pull it again. Again, that's a lot of steps that you have to do. So fundamentally, this will only give you 5,000 ton per hour. Again, you can have a bit more automation. This is American system, but inherently you're not going to go much. But you go to Colombia, they roll. They know how to roll. Their couplers are designed to rotate. That's why they can rotate. Basically, there is no disconnection. This is physically connected to this one. Airlines is also connected. They do not disconnect it. So train comes, a lock. Basically, you do have to hold the wagon from all sides, not only the wheels, but everything has to be held. You hold it. So that's the critical aspect. That's why this puppy can hit 1500 tons, because train can move much faster. There is no connecting, disconnecting, coupling, none of that. It's just like move. So this is much faster. This is cheaper. But again, they are brutal on the wagons. Now, steel has this advantage that it will not fatigue if you are below its fatigue limit. Like, you can keep using it. But friction, start-stop, basically joints, welds, yeah, those things do not last forever. So these things are rough on the wagons, meaning technically if you are using the wagon and you are loading from top, unloading from the top, these puppy will last 50 years. But if you go hutung, hutung, yeah, they will not last even 10 years. Like, you have to service them regularly. So they are brutal on the assets, so to say. Like, they are so brutal, even Indian government is like, yeah, as in Indian Railway, it's like, yeah, we don't want this. This works cheap enough, but it's very brutal. And again, we have to spend money on basically what you call this machine that does the dumping, and not to mention the wagon servicing cost goes up. Then we come to hopper. Hopper is, the idea is you have the same box, a bucket, but what if you have doors on it? Doors that you can control. That's a good solution. You do not have to tip it. You can just open the door, and it will cost more. The wagon will cost more. Per wagon would be more, but the collection area will become cheap. For example, this is the American system and European system, where you can see it literally has a giant V-shaped door on the bottom. It's like, psh, done. Then go home. Like, there is no disconnection, no airlines, nothing. You just psh, psh, done. This sort of wagon, which is side dumping, again, all countries have this, because again, that's the only way to roll ballast stones on top of the railway tracks. So you laid out the fresh track. There is a track laying machine. How do you encapsulate it in stones? This sort of wagon does that. Now, again, in Indian design, the door is mechanical, as in like some person is doing it. Some designs have hydraulic doors, some designs have electrical doors, some have pneumatic. This is India's option to that, where it's like coal goes through the bottom area rather than flipping the wagon. Although I'm genuinely confused, like, this is built, like, okay, we built it as cheap as possible, we built it as robust as possible, and it has 2 doors, so it can dump very quickly, great. It has pneumatic systems, ultra great. How the heck you charge that pneumatic system? Yeah, you take a guy with a wand, it goes into the air cylinders, psh, opens, psh, close. That was like, that's the silly part. Like, this is a European system where it's just have a handle. It's like, shh, you don't have to do much. It's like a bit messy. It's like, at some point, like, you know, cost cutting becomes a bit too much. But again, it does work much better than the dumping the whole wagon. So it is there. Basically, operation could be manual or automatic. Again, almost all of these are generally manual, because you don't want to risk a scenario where it's like, oh, the trains were driving and you pooped out all your coal. Because in rail scenario, it will catch on fire instantaneously and it will be bad. So that is there. And again, these ballastrons, so you do want manual, or if it is automatic, you want robust automatic where it cannot poop the pant. So you generally get side or bottom doors. Side doors are generally used for laying ballast stones. Bottoms, whenever you want to do dumping, as in coal, iron ore, those sort of heavy puppies. I have not seen anyone using it for sand, but again, I don't think we move that much sand anywhere. Backbone of railway, let that be very clear. Like, without this, there is no railway anywhere, even in America. In American one, you will find tiny solar panels. And you're like, what does that? Door controller. So it's there. It does require regular seal for the maintenance, because again, you are talking about giant amount of stuff. The seal has to be tight. And because it's a harsh environment, you are not putting a rubber gasket seal there. It's metal on metal seal. So it has to be very tight, like almost sub a millimeter. That's the sweet spot. If it touches like flat on, great. But again, you're talking about rocks and stuff. It will erode, it will become bumpy. But as long as it's below 1 millimeter, it should be good enough. It should be able to hold on to, like, you know, coal and something like that. And depending what kind of coal you have. If it's dusty coal, and if you are talking about iron ore, then you might require a much bigger seal area. So because again, it's almost like powder. you may require a bit more oomph, bit more clamping oomph. So hoppers are the what you call workhorse today, where you don't want to dunk the whole carriage. This is the workhorse today. This can dump very high speed. The problem is, ideally you would want a massive yard where you can dump everything. But again, you're talking about train. It could be kilometer or kilometers long. It's not practical. So generally, all the coal power plants, they will have a yard that can dump like 6, 7, or maybe 10, rakes in one go. So there is a speed limit. This sort of system is a bit more quicker, so they can have a train just pulling. Psh, psh, you can do like that, but it does require human intervention. So this is the hopper design. It's basically a quiet workhorse that we have slowly replaced the dumping system with this system. Now we come to Helix system. I would urge you to watch this. Like somebody, you would have seen a lot of designs of railway system which are like, this design is from 1950, this design is from 1930, that design 1930 is from, like, it's unbroken chain of refinement on, like, so now let's talk about Helix. Basically, Helix is a unique look, because you have to see, whenever you are watching some sort of this sort of system, you will find that most times they are literally taking the legacy of 1800s. Basically, oh, back then that's what we did. Like, there is no what you call fresh, like, brand new design. This is the only thing I've seen in a wagon technology that's like, oh, this is genuinely new. Because here's still, what if you don't want to stop? Like you're stopping, right? What if you don't? What if you can dump the material while the train is moving? And I do not mean like tuk 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 tuk. No, it is a smooth motion. You don't do that, and you do not have to worry about seals. Doors are great, but as long as there is seal, it's always weak, especially if you're dealing with something dusty. So what if you do that? Well, you put wheels on a pivoting rail. Basically, this is a normal bogie. There's a structure on the bogie. Bogie has a, basically that structure has a pivot. Pivot has the bucket. And you're like, wait a minute. Wheels are here. The bucket is going below. Yes, that's the whole point. Buckets goes from, it dumps the material. And how the heck you accomplish that? Well, no hydraulics are needed. No pneumatics, nothing. It's literally that wheel on top. So this almost sine wave looking like roller coaster path, that path is doing the tipping action. And the way they designed it, this is the brilliant part, you don't have to move it. Once you start the system, because you are talking about like iron ore dumping, it will pull it down, right? Like that lip will have so much iron ore that pull it down. Here's the deal. You pull it down, it dumps the material. But here's the deal. Because you are on a sine wave path, basically it's a smooth path, it pushes the empty bucket forward. You don't even have to push it. There is no pushing. Like once it starts rolling, it will keep moving on its own. You don't have to do anything. There is no stopping. There is nothing. You just like, the only issue I could see if Indians wants to use this is that a lot of our railway is electrified. So electrical wiring on top would be difficult. How can we solve it? Very simply, just U-turn the train. And that would be the easiest way of hauling it. Or like we can have small, yeah, you can have electric locomotive on both ends. So in this scenario, it just pulls the pantograph down and the one sits on the other side. Because again, we do have long trains, like kilometer is normal. So it can, again, it's a bit messy, and be mindful, European system do have electrified system. So you just require a fancy U-turn. Again, that's the critical part. Like you do not have to do anything. It's just like basically train pushes it a little bit from the back, and then a train locomotive goes from the other side, pulls it from the other side. You don't have, and again, it's not even pulling. It's just like I'm there to maintain it. And how much dumping rate it has? 2,500 tons per hour. I do not know if you know this. That's huge. Like this puppy can fill a grain silo or what you call basically bulk cargo ship quickly. That's how fast that number is. Like this is brutally huge number. And again, there is no stopping. There is no jerky motion. Everything is smooth. Now, they specified very clearly, it could not have been built on cheap steel. The steel that are used here are robust steel. Now, again, this is iron ore. If we design it for coal, I'm pretty sure we can get around with cheap steel. But again, why? Because again, the most expensive asset is time. This solves your time. Again, reduces wear and tear. Once you built it, these puppy will last very long. This was introduced 15 years ago. It won in 2015, if I'm not mistaken, European Rail Innovation Award. Because again, it's genuinely new. I've never seen like somebody come like, hey, why we are using the same bucket design we had in 1900s? or like 1800s. Like, what if you have some new design? What if you pivoted the bucket? And like, yeah, we could pivot the bucket. So fundamentally, it's like, it's really unique. Like, you have a wheel, and again, oh, can't it turn on its own? No, it can't. It's hundreds of tons. It's not gonna pivot on its own. So you don't have to worry about it. So this is a genuinely happy to see, as in like truly unique, truly new. Now we come to the Ro-Ro concept. I've already made a detailed video about it, but again, on TLDR, every Tom, Dick and Harry wants to remove trucks from their roads. It's good for the environment, it's great for the road, it's great for people. Everybody hates trucks on their roads, but again, how do you remove it? Well, you have to put it on trains. Now, loading trucks on train, it's done like, ask any army, it's like, yeah, we have been doing it for 200 years. That's boring. Issue is, we can't load and unload trucks reliably. Basically, the current system is almost like a centipede kind of structure. It's like, you know, one by one, sequential. It's almost like a VCR. But we need CD, where it's like, hey, go to this track, dump this truck, the end. So there are three systems that have achieved this. One, you have overwhelmed system, which is Flexi Wagon. The idea is it's so hydraulic. It has all onboard generator, onboard hydraulics, and a huge bucket. The idea is you literally can park your railway track. Again, it does not even require platform. It does not require flat ground. It's like, bro, I have the ramp. It's like, I'm gonna drop the ramp, I'm gonna move the ramp, and you're gonna drive your truck. I'm gonna fold the ramp, move it out. It has hydraulic legs and everything. So this is overbuilt system, but it does work. Meaning you can stop your train, pivot out all the what you call platforms, and voila, not even platform, buckets, and voila. So you can see it has hydraulic legs. It's designed to be self-stabilized. So they looked at it and it's like, yeah, this is great, amazing, but hyper expensive per wagon wise. So it's like, okay, what if we cheap down a bit? It's like, okay, you do need concrete pad. So this is designed what we call a mega swing. Mega swing is like, but again, both of them, this had advantage that you can't drive through. You can come in, but you have to back out, or reversing. Basically, you will have one motion that is reversing, or in case of a mega swing, both motions are reverse swing. So then we come to LOHR, Lohor Motor Lore. Motor Lore is pivoting. You drive through as long as you have small truck. Generally, these are designed for trailer section of the semi-trailer, not the whole truck. This can handle whole truck. This can handle the semi-truck. Again, it locks on the kingpin or fifth wheel as they call it. So that is there. This one is the best design, but again, it's European, so it does not have the enough room to carry the whole truck. And again, the biggest hurdle with this design is that it requires dedicated this does not care. This minor inconvenience, this easily can be done. This is best in terms of throughput, worst in terms of infrastructure, because it requires literally turntable mechanism on top of the basically where you are loading the train. So it's that's the problem with it. Again, I am thinking about it and I'm designing a 3D model where to showcase how it would be done in Indian context. But if you can do that, like, this would be amazing. This will be the final step. You can reduce so much truck rather than building giant flyovers and like paying bonkers amount of money in diesel. Ta-da! Trains. And again, the trains in India have very large portion solar powered. Environment. So this would be the final step. Like this, I have to say, like, somebody was like, looking, money is no object, built it. They built it. They're like, okay, money is somewhat object. It's like, you know, what's the best we can do? High throughput, everything like super easy driving, and it's like, yeah, European design, 4 foot, like take Indian broad gauge, chop off 1 foot. That's how small European system. Even their tunnels are small. So I can understand why they don't have like the whole truck parking. So this is the next step evolution that we have to figure out. So this was my presentation on unique, basically, freight locomotives or wagons. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. If you have enjoyed it, click the hype button.